So we give a minute for people to come in. Okay, let's get started. So today we're gonna go over limits, which is majority of your homework. So let's start. Uh, yeah, another reason I use whiteboard is because if I use like a different writing utensil or writing app, like I can't just it like changes tabs, so I won't know if anyone's like in the waiting room. So okay. Uh, so we read this as limit x goes to a, f of x is L. So that's how you read it, but the way you should think of it is as x goes to a, f of x gets close to L. So no, we only care about getting close, right? Let me just say we don't care about value at A. So we don't really care what F is at A. We only care about where F goes to as X goes to A. And we have a notion of, you can go to A in many ways, right? So I guess if you like gets close to A. So limit X goes to A from the left. So we read it like from the left. So don't confuse this, right? Like if it's a negative number, like this means like -1 from the left. So we write so negative sign on like the right side means from the left. Well, okay. Means limit as x approaches A from the left. And similarly, we have from the right. Is A from the right. So how you should think of this is like, for example, if like I have limit x goes to 2 plus, right? It's gonna be from this side, right? So you're taking numbers like 2.001, 2.00001, right? And then from the left, you're taking numbers like 1.99999, stuff like that, right? So and same for any other number. So note we haven't really defined limit going to infinity yet. So these are like numbers for now. Is everyone clear so far on definition? So nothing too bad. So we have I don't know if they don't write it as a theorem, so I'm gonna just say result. So limit x goes to A of f of x is L. So a limit exists and it's L if and only if limit x goes to A from the left is L. And sorry, there should be and limit x goes to A from the right is L. So they have to both be L, yeah. So a lot of things are being implied here. So if either the left and right doesn't exist, so if it's like infinity or it's not a fixed number, so it doesn't approach anything, your limit doesn't exist. And it could be possible that these both exist, but they're not equal, like they're not the same. So if they're not the same, your limit also doesn't exist. So let's do an example of this, yeah? So bear with me, this isn't graph paper, so I have to, not good at drawing either. So -4, 1. So let's do an example. Yeah, so 1, 2, 3, 4, -1. Yeah, I'm just gonna make something up. Like, oh, I should be clear. Okay, so this thing matches the 3, yeah, and this point is at 1. So okay, and let's move here, right? Move here all the way to. So this should be a straight line, and then circle at 1, and then a point at 2, and then it goes down. Yeah. Let's do this. This is F. Yeah. So as a class, let's figure out some stuff. So let's figure out limit x goes to -3 from the right. What is this? No, it shouldn't. It's not -1, and it's not -3 either. So, I mean, just think about it, right? As x approaches -3, where does f of x approach, right? So let me put it in red. As you go to -3 from the right, you're approaching 1, right? Everyone see that? I put it in red. So this is 1, right? Now limit x goes to -3 from the left. What is that? Not -3. So it's 3. Yeah. So if I'm approaching -3 from the left, I'm approaching this way, right? I'm approaching with points be smaller than -3. Yeah. So so you see that this is 3. It's easy. That's why I said before, like this might look confusing because it's like -3 minus. So this is 3. So question, what is limit x goes to -3 of f of x? Using the theorem I just quoted. So, or theorem or result. So yeah, doesn't exist, right? Because left and right are not equal. Okay. Everyone good so far? Yes, no. So nothing too complicated. Okay, so let's do something different. So let me make up another number. We're gonna do 3 numbers, so because it'll cover all the cases you'll probably have on your homework. All right, limit x goes to -1. Let's start from the right first, for example. So what is this? This is a plus sign, by the way. Yeah, it's 1, right? I mean, pretty easy to see. All right, what about limit x goes to -1 from the left? What is that? Yeah, it's still -1, right? Like that. So you see that here, it's gonna be 1. So what is limit x goes to -1 since the left and right are equal, it's 1, right? So this is 1. Let's do the last one. So this is the last case you'll probably get on your homework. So limit x goes to 1. What about limit x goes to 1 from the right? Yeah, it's 1, right? So let me put in red. It's going to 1, right? So, and then limit x goes to 1 from the left. What is that? Yeah, it's also 1. So, I mean, I'll put in red. So you see that limit x goes to 1 of f of x is 1. So you see this part right here is a classic example of the statement I just wrote before, right? Right here. We don't care about the value at the actual point, right? Because you see here, like, we don't care, like the value is right here. The value of the point I want is right here. But I mean, but limit, we don't care about the actual value, right? We care about what it goes to. So hopefully you all see the difference there. So in the case where it is equal to what the value of the function is, the word is called continuity, but you'll learn that like in a few weeks, not now. So just know, like, for limits, we care about what it goes to, not what the value of the function is. Everyone clear on this so far? Okay. Let's continue. So you can see that there's like several ways limit won't exist, right? So it could be that limit is plus minus infinity, right? Because when I write L is like a number, yeah? So, and I guess I never really define what it means, you plus minus infinity, but you can see, like, if it's like plus infinity, like, values get arbitrarily large. And minus infinity, values get arbitrarily small. I don't know if this is how you spell arbitrarily, by the way. Probably spelled it wrong. Okay. And then another reason would be right is not equal to left, right? So it could be, and by limit I mean like all, either from left, right, or both, right? And then the second case is it might not be plus minus infinity, right? It could be a finite number, but the two finite numbers are not equal, right? Kind of like the example we saw before. And then another way is like a function does not approach any specific number. So a classic example, so I mean, we saw examples of this, right? Like just one slide before, right? A classic example of like the third part would be like f of x is, let me think, this should work. Yes. 1 over x. So I'm saying limit x goes to 0 of f of x, does not exist. And the reason is because it doesn't really approach a specific number, because you can go to 0 in like many ways, right? So one way would be you could go to 0 like this, 1 over 2 pi, 1 over 4 pi, 1 over 6 pi, so on and so forth. So in this case, what is f? What is f of 1 over 2 pi? F of 1 over 4 pi? F of 1 over 6 pi? So this is sine, for example, f of 1 over 2 pi is sine of 1 over 1 over 2 pi, which is sine of 2 pi. And what's sine of 2 pi? Hopefully you all remember your trick. So yeah, 0, right? Any 2 pi multiple is 0. So this is just 0, 0, 0, 0. So you see, in this case, you're going to 0, but I can also have x go to 0 in which the f of x doesn't go to 0, right? I could do pi over 2, right? 1 over pi over 2. 1 over pi over 2 plus 2 pi. 1 over pi over 2 plus 4 pi. So on and so forth, right? In this case, you can see sine of 1 over pi over 2. This looks really nasty. 1 over pi over 2 is just sine of pi over 2. And sine of pi over 2 is 1, right? And you can see sine is 2 pi periodic, so this is just 1. So I have, in both cases, this sequence is like going to 0, right? Because my denominator is getting bigger and bigger. So, but on one case, one of them is going to 1 and one of them is going to 0. So you see that it doesn't really approach a specific number, right? If you're like approaching 2 different numbers, you can't be approaching like one specific number. Is everyone clear so far? There's an easier example, like limit to infinity, right? So if you think of sine, but we never really define x going to infinity yet, so I don't want to go over that. But you can see if you keep going on to infinity, sine does not approach anything, right? It's like oscillating, like it can't possibly approach something if it keeps waving, like wave after wave after wave, right? So yeah. So that's like an example of the third one. So I'm gonna go over an example of like the first one. But is everyone clear so far on this? Yes? No? Okay. So moving on. So we have something like limit x goes. Let's do something really. So let's try to figure out what this is. Yeah. So in doing this, right? So for limits, before I do this, if you're given like an equation, like given equation, right? Like limit x goes to a f of x, the first thing you do is plug in. Plug in a, right? So if you get a number, right? Done. If not, I'll just say try harder. Yeah. Basically, you got to do something, like do something special. Whether it's, and then we'll see examples of this. So, but always plug in first, right? Because if you plug in and you get a number, you're done. Like there's no issue, right? So in this case, for example, if you try plugging in 0, you get 1 over 0. So if you get 1 over 0, that's not a number, right? It's undefined. So you don't know the answer immediately, right? Like what I mean by this is if you have something like, I don't know, limit x goes to 1, x squared plus 2x plus 4. Plug it in, like plug in 1 squared plus 2 plus 4, you get 7. That's your answer. So if you plug in and you get something valid, you're done. So, but in this case, you don't, right? Because you get 1 over 0. So let's think about this. If I'm dividing by, remember, I don't really care about the value at the point, right? So if I'm getting close to 0, so let's say I'm coming from the right, right? So limit x goes to 0 plus. So think of really small numbers, right? Like 1 over a million. So if I plug in 1 over 1 million to my function, does my number get really big or really small? After I plug into my function, I mean. So think of it this way. Like if I'm plugging in x equals, plug in x equals 1 over 1 million. It's big, right? Because f of x would be 1 over 1 million, which is 1 million, right? So the way you think about it is, I guess when I say big, you know, like, does it get big in like absolute value? So, right, because if you're getting close to 0, right, you're basically having like really small denominators. So like you're this is a really small number, right? Like 1 over 1 million. And if you get closer and closer to 0, you have like 1 over a trillion, 1 over 1 trillion, so on and so forth, right? So you see, this thing becomes really big, right? So what do you think it's going to as you approach 0 from the right, as you get closer and closer to 0? Yeah. Pause infinity, right? So that would be the easy way. I mean, I guess the easier way would be the graph, because you could graph this, but you know, if you since you know the graph in this case, right? As you get close to 0, you're blowing up. You're going to infinity, right? But really, the better way to think of this is if you divide by a really small number, you get a really big number. That's the idea, right? If you divide by a really small number, you get a really big number in like absolute value, I mean. So similarly, if you approach 0 from the left, right? So by the way, since this is positive infinity, that the limit, you know, doesn't exist already, but you know, so limit as you go, so this is, you know, does not exist. But you know, here, right? If I go from the left, so we're already done with the question, but let me just ask another question. What is this limit if I approach 0 from the left? So again, this is, or if you like, DNE. If I approach 0 from the left, where do I go? So I'm still dividing by a really small number, right? In a sense, right? I'm dividing by like negative 1 over 1 trillion. So it's getting big in like absolute value. So you see that this is getting big, but it's going to like negative infinity, right? Like your output in this case, like if x is negative 1 over 1 million, right? F of x is 1 over, which is negative 1 million. Yeah. So I think your book would, huh? So I mean, I don't know what you're talking, but like, I'm assuming as an example like this, right? So like in this example, we figured that the only issue was here, right? So I mean, I don't know if it's either they have a arrow here, so you would write, you know, -4 to -3, or you write negative infinity. So for me, it goes off to negative infinity. So I mean, the limit exists, right? On like uh, open parenthesis and then -3 to infinity. Yeah. So it's either this or like if the book doesn't count like everything beyond, I guess you would, from my picture, it would be like Sorry, there's bracket, comma, comma. Yeah, because limit exists everywhere else, right? So limit exists. Okay, is everyone clear on this idea? So you need to understand this because they're in the future you have to see, oh, this is this is positive infinity, this is negative infinity, so on and so forth. Does everyone understand like dividing by really small number gives really big number? Yes, no. Okay, so moving on, we have a word for this. So there, let me just write, there is a word for limits being infinity or negative infinity, right? So the definition is, so we say a line, so x equals a. So is, before I write anything, if a is a number, x equals some number, is this a vertical line or a horizontal line? Like x equals, yeah, it's vertical. Yeah, so we say x is a vertical asymptote. That's where the vertical comes in, by the way. So we'll define horizontal asymptote like later on. So of y equals f of x. Basically, you know, if you, this is the actual definition. So if at least one of the following is true, limit x goes, basically when you get limit is infinity. Limit x goes to a, f of x is infinity. Limit x goes to a, f of x is negative infinity. Limit x goes to a minus f of x is, so again, this minus is not negative a, it's as you approach a from the left. So I guess this really confuses students because so I feel honestly the better way to think of it is it's an x value where your function blows up. Yeah, by function, so you know, blows up means going to positive infinity or negative infinity. So the way, if you don't like this definition, just think of it as like an x value where like your function just blows up, right? Goes off to infinity or goes off to minus infinity. So like from before, if you just graph this, right? If you just graph 1 over x, you see that the vertical asymptote is at 0 because it goes off to positive infinity and negative infinity at 0. So everyone clear? So we're going to do examples, but is everyone clear on the definition? Yes, no. Okay, so let's do examples on finding vertical asymptotes. So find vertical asymptote. So here, let me do something a bit less tricky, and then x minus 3, x minus 7. So again, ignore that. Just ask yourself, when does the function blow up? So another way to ask this is, you know, again, we saw an instance where it blows up, right? It blows up if you have a number that's not 0 and then you're dividing by 0, right? Because if you divide by 0 as you approach from the left and right, you're going to blow up to like infinity or negative infinity, right? So one way to answer this is, in this case, is yeah, when are you dividing by 0, right? when you have a number divided by 0. So it's important you have a number, right, on top. So if I plug in 3 on top, I get 3 squared plus 1, right? As long as the number is non-zero. So, because if you have 0 over 0, things might cancel out. So I'll go over that later. But yeah, you see here, it's going to be, let's just do it for practice, right? Limit x goes to 3 from the right is what? So again, for this, if you just plug it in, you're dividing by 0. You have a number divided by 0. So you know the answer is either, since you're approaching from left or right, it's either positive infinity or negative infinity. So is it positive or negative? Well, just check, right? Plug in a point. So if I'm approaching 3 from the right, let's take 3.1. If I plug in 3.1 on top, do I get a positive or negative number? Yeah, positive on top, right? So I get a positive number. So let me just put plus. Now if I put in here, right, if I plug in 3.1, I get positive number here, right? Because 3.1 minus 3 is positive. 3.1 minus 7 is negative, right? So what is a positive times negative number? Do I get a positive number or a negative number? Yeah, negative, right? And then I'm dividing a positive by a negative. Do I get a positive number or a negative number? Yeah, so you see in this case, it's negative infinity, right? So let me just, and then you could play the same game, and then you'll see that this is, it's gonna be positive infinity. Yeah, because in this case, you'll be plugging in something like 2.9 instead of 3.1. So, but in any case, this is satisfied, right? So I got limit x goes to 3 from the right is negative infinity. So you see from here, right? I satisfy this part, right? Limit x goes to a from the right is negative infinity. Once you have that, a is a vertical asymptote. Like you don't need to check all of these, right? You just need to check one of them. Remember, it's at least one. So once you have one, you get that 3 is a vertical. So 3 for x equals 3 vertical asymptote. And similarly, let me just say similarly, x equals 7 vertical asymptote. Everyone good so far? Yes? No? So let me just quiz you. Find vertical asymptote of e to the x. So remember, x equals a is a number. So is there any particular number where e to the x blows up or goes off to infinity? If you just graph it. Is there a particular number where, you blow up? No, right? I mean, you certainly blow up when you go off to infinity, but there's no number where you do, right? So that there's no vertical asymptote. Okay. Now, let me give you a more trickier question. But before that, let me ask you, what's limit x goes to 3 x squared? So I think this is also on your homework, by the way. You might have a case of this. So again, I told you like 20 minutes before, rule of thumb, if you have something like this, plug in. If you plug in and you get a number, you are done. So Sadly, the examples I put, you're not done. So if, if you plugged in, right? So plug in, what do you get? 3 squared minus 15 plus 6, 0. And then here it's 0, right? Hopefully I made it. Yeah, it is 0. So in this case, whenever you get 0 over 0, so before, right, we got for like 1 over x, it's a number, non-zero number, so non-zero number over 0, right, if you plugged it in. So in that case, it was, you knew the left and right were like plus minus infinity because you're dividing a non-zero number by a really small number. But in this case, right, you have 0 over 0, right? The top is also 0. In this case, your answer might not be infinity, right? In this case, I'm saying there is some cancellation. Let me just say cancellation or algebra to be done. Yeah. So in this case, it's obvious, right? I mean, the first thing you would do is factor, right? So you would say, how do I factor x squared minus 5x plus 6? Well, this is x minus 3, x minus 2, right? And then the bottom is x minus 5, x minus 3. So you see these cancel, right? Everyone see that? So these cancel. So this limit x goes to 3, x minus 5. And now if you plug in, this is the number. So 1 over negative 5. Or sorry, I don't know why I put negative 5. 1 over negative 2. So negative 1/2. So what you're going to see is you should be careful, right? So if the question was find vertical asymptote, of this, if you just said 0 denominator, it's not correct, right? So I'm saying x equals 3 is not vertical asymptote, right? Because it doesn't blow up. The limit as you go to 3 is right here, right? It's negative 1/2. In this case, it's only x equals 5, right? So I'm saying when you plug in, is not only do you check if you divide by 0, but make sure the top number is non-zero. If the top number is non-zero, then like, yeah, it's a vertical asymptote. But in the case you get 0 over 0, it's you still have to work harder. But yes, it's still a discontinuity. But like, I mean, so let me just say this. To define discontinuity, I would need to define continuity. And we never defined continuity yet. So I don't want to introduce something professor didn't introduce yet. So yeah, but we'll get to that later. Yeah. So, but for now, make sure, so in this case, it's not a vertical asymptote because the limit is negative 1/2, right? It's only a vertical asymptote if you get, plus or minus infinity. But I don't think that's the question on your homework. I think your homework is just something like this, where when you plug in, you get 0 over 0. And in that case, is work harder. And another example, I don't have one at the top of my head, but another 0 over 0 case involves square root. And in that case, you just multiply by the conjugate. Yeah, so my advice would be multiply by conjugate. In case people don't know what conjugate is, right? Like so let me just try to think one on the top of my head. Or do you have an example on the homework of like a square root? Let me just think of one. 3, or if anyone can give me one. I'm not good at making up examples, but like if you have something like this, right? It'll probably look like something like this. Something here. So I'm saying to simplify this, you would multiply by this. Yeah. So no, I'm not changing the question because this thing is just 1. I'm just multiplying by 1, but in a smart way. But you see here, right? What is this, right? You have a plus b times a minus b, right, is a squared plus b squared, right? So you, in this case, right, this is your a, this is your b. And when you square a square root, right, squaring a square root just undoes the square root, right? So you have x plus 3 minus 9 squared, right? So you basically got rid of the square root on the bottom. So if hopefully that, I'm not sure if they have this question, but hopefully that helps you on the homework. I'm not sure if, I believe I saw a square root problem on the homework. I might be, I might be going crazy, but yeah. So if you plug in, you get 0, 0, you multiply by the conjugate, yeah? So, and then you use this law. And what you're gonna see is things will cancel out when you simplify. And that's exactly what I mean, right? Like here, there is some cancellation in algebra. So the algebra would be multiplied by conjugate, and then things will cancel. Everyone clear so far? Yes? No? Okay. So actually, I think it's good. I just wrote it like this because I mean I don't want to do the homework for you. Let's do one last thing. So f of x is all right, no problem. So f of x is e to the x. So this is similar. So this is e to x if x less than or equal to 0. So I'm doing everything. So before I drew the piecewise function, now I'm writing it as an equation. Right? So here, this is a piecewise function if x greater than or equal to 1. So before, right, like this one, this is an example of a piecewise function, right? So except I just graphed it. So here I'm giving you the formulas instead. So if I were you, I would not graph, do not waste time graphing it unless the question says graph it, right? So limit x goes to, if the question is what's limit x goes to 0 f of x, right? It's the same exact thing. In fact, I think it's easier when you have the equation, because what you do is limit x goes to 0 from the right. So here's my first question. If we're approaching 0 from the right, am I bigger than 0 or less than 0? If I'm approaching from the right, or my x, yeah, bigger. So which equation should I use if I'm bigger than 0? If I'm so close to 0, right? So I'm certainly smaller than 1. So I'm using this one, right? So in this case, it's just limit x goes to 0 from the right x minus 1. And this one you can just plug in, right? Just -1. Plug in 0, right? I told you, if you could plug in, you're done. All right, now x goes to 0 from the left. So first question you ask yourself, right? If I'm approaching from the left, am I approaching with numbers bigger than 0 or less than or smaller than 0? Yeah, so which equation should I use? Yeah, this one, right? E to the x. And that's how you could plug in too, e to the 0. E to the 0 is 1. right? So let me just conclude with the last one. So hopefully you know what I'm asking. Limit x goes to 1 f of x. Same exact thing. There's nothing tricky with this. So in this case, right, does not exist, right? Because the left and right are not equal. So now limit x goes to 1 from the right, f of x. What is this? So same exact question. If I'm approaching 1 from the right, I am bigger or smaller than 1? If I'm approaching 1 from the right. Bigger. So what equation should I use? Yeah, this one, right? ln. So this is ln x, and then ln of 1 is 0. Yeah. And then limit x goes to 1 from the left. Right? If I'm approaching from the left, I'm approaching with numbers smaller than 1, right? So I should be using x minus 1. Agree? And in this case, it's also 0. 1 minus 1 is 0. So this limit is 0. Everyone clear on this? Hopefully the homework should be easier now. Okay. Yeah, so that's all I have for today. So I guess on Tuesday we'll go more in depth into limits and like horizontal asymptotes and stuff. But yeah.